I will discuss infinite limits today. So when evaluating limits and what you get is a constant over zero, then your answer will either be positive infinity or negative infinity. Remember, without the concept of limits, when you just evaluate the value of 6, for example, over 0, then we say that this is undefined because there is no such number in the set of real numbers that will define the quotient 6 over 0. But if we try to evaluate the limit of, for example, 6 over x squared as x approaches 0 from the right, and we try to substitute 0 for x, then we get 6 over 0. So remembering this concept that I have written, that whenever you get a constant over 0 when evaluating limits, then you either get a positive infinity or a negative infinity. So here's how to identify which of the two will be your answer. So looking at the denominator, we have a positive number, 6. It's always a positive number because we have a constant in the numerator. Now, as x approaches 0 from the right, okay, so it means to say that x is a number very, very close to 0, but from the right of 0, so it means to say that x is still positive, okay, but very close to 0. Now, x squared here, when x is positive, will always be a positive number, but it's a very, very small number, even closer to 0, so the denominator is positive. Okay, but remember that the denominator is a very, very small number. So the constant 6 positive divided by another positive, very, very small positive number will approach positive infinity. Now you get the sign of infinity by dividing a positive number by another positive number, so the quotient is a positive number also. Let this be our example 1. Now for our example 2, the limit of the same function 6 over x squared. This time as x approaches 0 from the left. Now again, substituting 0 for x. Well, remember that we are not actually substituting the 0 exactly for x. We are actually substituting a number very, very close to 0. So, but still we get 6 over 0. Okay, so the answer will either be a positive infinity or a negative infinity. Now again, we have to look at the signs of the numerator and the denominator. Again, the numerator is always positive 6. It will not change. Now, as x approaches 0 from the left, then it means to say that x is a number very close to 0, but a negative number. Now, the denominator is x squared. So, substituting a negative, very, very small negative number for x squared will still be positive. So the denominator remains positive. And so a positive number divided by another positive number, the quotient is a positive number. So it's positive infinity. So it's actually 6 being divided by a number very, very close to 0. So the quotient will be approaching positive infinity. That's our answer. Now for example number 3, let's take the limit of negative 4 over x plus 2 as x approaches negative 2 from the right. Now substituting negative 2 for x again, we get the negative 4 over negative 2 plus 2. And our answer will be a constant negative 4 over 0. So the answer will either be a positive infinity or a negative infinity. Now looking at the signs of the numerator and the denominator, the numerator is a constant negative 4, so it's always a negative number. Now as x approaches negative 2 from the right, it means to say that x is a number very, very close to negative 2, but from the right of negative 2, so it must be greater than negative 2. Substituting a number which is very close to negative 2 but greater than negative 2, what happens to the sign of the denominator? It becomes what? Positive, right? So let's take a number very close to negative 2 but greater than negative 2. Say it's Let's take negative 1.9999. Okay, so it's very close to negative 2, but from the right of negative 2. So substituting negative 2 for negative 1.999 for x, we get the value of a positive number. Right? So x plus 2 is a positive number whenever x approaches negative 2 from the right. So now we have here the quotient of a negative number and a positive number. So the quotient is a negative number. So it's negative infinity. For number 4, let's evaluate the limit of the same function, negative 4 over x plus 2, as x approaches negative 2 from the left. So substituting negative 2 for x, we get negative 4 over negative 2 plus 2. The answer is, again, a negative 4 over 0. So the sign of the numerator remains the same. It's still a negative number. Now let's look at the sign of the denominator as x approaches negative 2 from the left. So as x approaches negative 2 from the left, it means to say that x is a number very close to negative 2 but less than negative 2. Let's take a number very close to negative 2 on the left, on its left. So let's say negative 2.0001. Okay, when x is equal to negative 2.001, what happens to the sign of x plus 2? It becomes negative, right? Okay, so we now have a quotient of a negative number and another negative number. So their quotient is a positive number, so therefore the answer here is positive infinity. Let's take another example and evaluate the limit of, let's have limit of x minus 2 over x plus 3 as x approaches negative 3 from the right, let's say. So substituting negative 3 for x, we'll get a negative 3 minus 2 over negative 3 plus 3. So that is a constant negative 5 over 0. Okay, so again, let's look at the sign of the numerator and the denominator. The numerator is a negative 5. The numerator is always a negative number whenever x approaches negative 3 from the right. Okay, so let's try to look at the sign of the denominator as x approaches negative 3 from the right. So it's a number very close to negative 3, but from the right of negative 3. So this x here must be greater than negative 3. So let's say the number x is a negative 2.9999. Okay, so if it's a negative 2.9999, what happens to the sign of x plus 3? So it becomes positive. Okay, so it's a positive number. Now we have a quotient of a negative number and a positive number. So the quotient would be a negative number also. So the sign of infinity sign is negative infinity. What if we have in number 7 the limit of the same function x minus 2 over x plus 3 as x approaches negative 3 from the left. So it's still a negative 3 minus 2 divided by negative 3 plus 3. So it's still a negative 5 over 0. Now let's look at the signs of the numerator and denominator as x approaches negative 3 from the left. This is always a negative number as x approaches negative 3. So what about the denominator? As x approaches negative 3 from the left, so it means to say that x here is a number very close to negative 3 but less than negative 3. Let's take a number from the left of negative 3. Let's say negative 3.0001. Then x plus 3 here will be a negative number. Right? So the sign of the denominator is negative whenever x approaches negative 3 from the left. So we have the quotient of a negative number and another negative number, the quotient would be a positive number. So this is positive infinity. One last example. We take the limit of x minus 1 over x squared times x plus 2 as x approaches 0. Let's take from the right. Okay, so it's from the right of 0, so 0 minus 1 over 0 squared times 0 plus 2. So this is a negative 1 over 0. So the sign of the numerator is negative. Negative. This is the negative number. So as x approaches 0 from the right, the numerator will always be a negative number. What about the denominator? Okay, as x approaches 0 from the right, so x here is a number very close to 0 but greater than 0. Let us take 0.0001. So whenever x is a number very close to 0 but greater than 0, this is always a positive number. Multiplied by x plus 2 will be another positive number. So the denominator, so positive times positive, will give us a positive product. So x squared times x plus 2 in the denominator is a positive number. So therefore, we have the quotient of a negative number here and a very, very small positive number. And so, quotient will be a negative number. So this is equal to negative infinity. So when evaluating limits, we don't get the term undefined. Okay? We don't get the term undefined. So not this term. So it's either positive infinity or negative infinity. So graphically, what does a positive infinity or negative infinity imply? Whenever you evaluate the limit of a function as x approaches a from the right, and you get either positive or negative infinity, or when evaluating limits as of f of x as x approaches a from the left, is equal to either of the two, positive infinity or negative infinity, or when evaluating the limit. So in general, when evaluating the limit of the function as x approaches a, and you get either positive infinity or negative infinity, this means to say, so graphically, it means you have a vertical asymptote. Vertical asymptote at x equals a. Okay, x equals a, you get the number a here. So in the first example a while ago, the limit of 6 over x squared as x approaches 0 from the right is a positive infinity. So it means to say that there is a vertical asymptote whose equation is x equals 0. Okay, 0 from this number. Now the limit of f of x, 6 over x squared as x approaches 0 from the left, is also equal to positive infinity according to our second example. So the vertical asymptote is still at x equals 0 because of this number. Alright? In the next example, we have the limit of the function, if I'm not mistaken, negative 4 over x plus 2 as x approaches negative 2 from the right. What we got here was a negative infinity. So it means to say that there's a vertical asymptote at x equals negative 2. Okay, negative 2 again was obtained from this number, x equals a. So for the limit of negative 4 over x plus 2 as x approaches negative 2 from the left. So our answer here was positive infinity. Therefore, the vertical asymptote of the function f of x equals negative 4 over x plus 2 is x equals negative 2. I think our number 5 example was the limit of x minus 2 over x plus 3 as x approaches negative 3 from the right. Our answer here was positive infinity. So the limit of f of x as x approaches negative 3 from the right is equal to positive infinity. So there's a vertical asymptote at x equals negative 3. So negative 3 was obtained from this number again. Okay, the function in number 6 is the same. So the vertical asymptote remains the same. It's x equals negative 3. In example number 7, we have the limit of x minus 1 over x squared times x plus 2 as x approaches 0 from the right, I think. So our answer here was negative infinity. So since the limit of the function f of x as x approaches 0 from the right is negative infinity, there is a vertical asymptote in the graph of the function, and its equation is x equals 0. Again, 0 was obtained from here. Right? So again, whenever you evaluate the limit of a function as x approaches a, either from the right or from the left of a, or generally as x approaches a, and what you get is any of this, positive infinity or a negative infinity, it means to say that graphically the function has a vertical asymptote at x equals a. Okay, thank you.